Unit 5 review, problem 13. It talks about being joint variation. Remember that joint variation means it varies directly with more than one variable. So our general equation for joint variation is z equals axy. They're asking us to find z when x equals 5 and y equals 6. But first thing we got to do is find this constant of variation. So that's why they give us these three values here. So I'm going to substitute them into our general equation, z equals axy. So 45 goes in place of the z. In place of x, we put the 1/4, and in place of y, we put 10. So 10 is 10 over 1. So 10 over 1 times 1 over 4 gives you 10/4. But that can reduce, because they're both divisible by 2, to 5/2. So if I want to solve for a, normally I would divide by this, but since this is a fraction, we never divide with fractions. Instead, we're going to multiply by the reciprocal. So we're going to multiply both sides by 2/5. So on the right-hand side, you get 10 over 10, and 10 divided by 10 is 1, so it's just 1a. On the left-hand side, remember 45 is over 1, so you do the 2 times 45 and get 90, and then the 5 times the 1 gives you 5. So you have 90 divided by 5, but that can evenly be divided. 5 goes into 9 one time with remainder of 4, so then it's 5 into 40, which is 8. So 90 divided by 5 gives you 18. So now we have our equation of variation, z equals 18xy. So that's our equation of variation. And now we're going to use that to answer their question, find z when x equals 5 and y equals 6. So in place of x, we put 5. In place of y, we put 6. So 5 times 6 is 30. So I'll put the 0 from the 30, and then 3 times 8 is 24. Carry the 2, 3 plus 2, 5. So you get 540. So for part A, your equation of variation was z equals 18xy, and then z, when x equals 5 and y equals 6, was 540. So they have to give you these three values so that you can do the first step, which is to find your constant of variation, so that you can write your equation of variation. And then you apply that equation to answer whatever question it is they're asking you to find this. So let's do one more example. So part B, they told you x equals 2/5, y equals 10/3, and z equals 10. So again, I've got to find my constant of variation. So I'm going to substitute those three values in. So z is 10, x is 2/5, y is 10/3. So 2 times 10 is 20, 5 times 3 is 15. But again, that can reduce. They're both divisible by 5. So if you divide them both by 5, you get 4/3. Again, to solve for a, I would want to divide by this, but it's a fraction. We never divide by fractions. Instead, I'm going to multiply by its reciprocal. So on the right, you'd get 12 divided by 12, which is 1. So you just have 1a. On the left side, remember 10 is really 10 over 1. So 3 times 10 gives you 30. And then 4 times 1 gives you 4. Well, 30 divided by 4 doesn't come out even, but you can reduce them both by 2. You get 15 over 2. So your equation of variation for this one, z equals 15/2 xy. Because again, it was joint variation, so joint means direct, where you're multiplying by them, and x is in the numerator, but there's more than one. It's not just x, it's x and y. So that's why this is our equation we're starting out with. We found our a, so we plug that in. That's your equation of variation. You use that to answer their question. So you plug in the x and y values they gave you. So again, 5 times 6 is 30. And if I take 30 times 15 over 2, remember 30 is 30 over 1. So I'm actually going to cross reduce this time, I think, rather than taking 15 times 30. I'm going to do the 30 divided by 2 first and get 15. So I've got 15 times 15, or 225. I hope that helps and you're able to figure out the third one.